Hello there, Mr. Sutton here, bringing you the 2025 MCAS solutions. This part of the video, we're going to be doing part 1, numbers 1 through 21. For this question, they're asking what the minimum value of x is that makes the following inequality true. So what we're going to do here is just solve this inequality for x following the rules of inequalities, and then we'll see what we can see in terms of minimum values. So if I want to get x by itself, first thing I need to do is subtract this 12 over to the other side. So that'll give me negative 8 on the right side. And when I do that, the inequality symbol does not change directions at all. I can add or subtract without changing the direction of that. At this point now, I need to divide by negative 2 to get x by itself. Now, when I multiply or divide by a negative, that is when my inequality has to change directions. So this is going to become x is greater than or equal to positive 4. And if I'm asking the smallest value of x that makes this true, well, this is all the values that are 4 or greater, so then 4 is going to be the smallest one that fits into this group here. So that would be choice C. For this problem, we have a circle with a shaded sector shown in the diagram, and the radius of the circle is 9 centimeters. And they also gave us the angle of the unshaded sector. That's important, and that's 160 degrees. They want to know which expression is equivalent to the area of the shaded sector. So we don't actually have to find the area, but we need to find an expression that would let us find the area. The way that these different answer choices are set up, this is looking like the sector area formula, which basically you're doing pi r squared, that's the area of the whole circle, and then you're just multiplying that by a fraction that has your angle over 360. So essentially the percentage of the circle that you're really trying to get the area for. So putting all that together, in degrees mode anyway, we're going to do theta over 360 and then times pi r squared. Now the theta that we're going to be using, that's the part of the circle that we want. That's this shaded area. To get this, I need to do 360 minus the 160 degrees that I've already used up here. So this is going to be 360 minus 160 over 360. And then for my radius, that's going to be 9. So I'll plug 9 in for r. So pi times 9 squared. Simplifying this just a little bit, I don't have to go too far. That's going to be 200 over 360 times pi times 9 squared. And I could go further, but looking at the answer choices, that's what I have in answer choice A, so I'm going to go with that one. On this problem, we're told that a student solved this equation here, and they want to know which table has the correct explanations for each step the student used. So if you look at all these different tables, the left column of each of these is actually identical. It's the same steps each time, but what's changing is the explanations that we're attaching to each of those steps. So we're just going to go through each table until we find a step that's incorrect, and by process of elimination, we'll figure out which one of these has all the right steps. So taking a look at table A, the first step here, they said given. Okay, that's true. And that's actually true on all these. They correctly wrote the problem each time. Next step, added 2 to both sides. Well, if we had added 2 to both sides, then we wouldn't still have this minus 2 here. We'd actually have a 7 over on the other side. So that's not what happened on that first step. Moving on to table B then, for their next step here, they said subtracted 3x from both sides. Well, we started with 17x and 3x, and now we've got 14x, and nothing else has changed. So yeah, definitely that's true. Now for their next step, they said subtracted 2 from both sides, and the minus 2 is gone, but if we had subtracted 2 from both sides, that actually would have given us 3 on the right side, not 7. So they had the right idea with the 2, but they did the wrong thing with the 2 in terms of the explanation. So that's a no, and it can't be choice B. Moving on to choice C, their kind of second step here is they said added 3x to both sides, and if they had done that, we would have had 20x, not 14x, so that is incorrect. So by process of elimination, it's looking like D is pretty good here, but let's just double check all the steps. So subtracted 3x from both sides. Yup, 17x minus 3x is 14x. Added 2 to both sides. Yes, 2 over here gives us 7, so that's a true one. And then divided both sides by 14. 7 over 14 is 1/2, so also true, so definitely choice D. On this problem, they want to know the value of the cube root of 64 squared. Now, you're actually allowed to do these in any order that you want. You could square first and then cube root, or cube root and then square. But since this is the no calculator part of the MCAS, I'm thinking it would be easier to find the cube root first and then square it. So what would I have to raise to the third power to get 64? Well, 4 times 4 times 4 is 64. So the cube root of 64 is going to be 4. So that means we really have 4 squared, 4 times 4, which is 16, giving us choice D. For this one, we're given the expression x squared minus 7x plus 10, and they want to know which x values make this thing come out to 0. And then select 2 answers. Okay. So one way you could do this is just start plugging in the answer choices carefully and see what makes this equal 0. Or if you want to use an algebraic approach, we're basically setting this thing equal to 0 and solving it. And we can do that by factoring and using our zero product property. So if I'm trying to factor this thing, since I have an a value of 1, this is just 1x squared, I can just ask myself, what are 2 numbers that multiply to 10 and add up to negative 7? So numbers that are factors of 10 that sum to negative 7. Well, there's not a lot of choices. We've got 1 and 10 and 2 and 5. 2 and 5 adds up to 7 if I make them both negative. So I'm going to split this up into x minus 2 and x minus 5, and I'll set all of that equal to 0. Now that I've done this, I just have to figure out values of x that zero out each of these parentheses individually. So if x minus 2 equals 0, then x equals 2. And if x minus 5 equals 0, then x equals 5. So that's going to be answer choices C and D. For this problem, we're told that Maya plays on her high school basketball team, and they're giving us a table that shows x, the number of minutes played, and y, the number of points she scored. And this is just the first 8 games of the season. So this is a multi-step problem, multi-part problem. Part A, they want us to take this coordinate plane and just create a scatter plot using the table data here. So we just have to graph each of these points, and that's all we need for part A. So we've got 10 and 4, so we're over 10 on the minutes and up 4 on the points, so we're right there. And then 14 and 10, so 14 and 10 is going to be up here. And then 14, 14, so going up a little higher. 16 and 12 brings us back down here. 16 and 14 is right up here. And then we have 18 and 16 is all the way up here. And then 18 and 18 is up here. And our last point is 20 and 17, so we're over 20, and we need half a grid line for 17. That's going to be between 16 and 18. And there we go. For part B on the problem, based on the data, they want to know which of the following describes the correlation between number of minutes Maya played and number of points she scored per game. All right, well, if we're asking about correlations and correlation coefficients and all that, we're essentially talking about a line of best fit. So we can approach this problem by trying to draw a line that goes through as many of these points as possible, comes as close as possible to all the points. So here's one possible such line. Just draw it like this. And this is roughly the same distance away if you add up all the distances between the points and the line. So next, let's look at the line and see what direction it's going. Positive or negative slope? Well, it's positive. So that tells us that this is going to be a positive correlation of some kind. So this could not be choices C or D. As she gets more minutes, she tends to score more points, which makes sense. Now, we also need to say, is it a strong or a weak one? And this is one where you have to kind of eyeball it, but it looks like we're coming pretty close to most of these points, and we're actually going through a number of them as well. Since we can draw a positive sloping line that comes close to all the points, I'd say strong positive correlation is the best answer to this one. For part C, based on the data, we want the expected number of points Maya will score if she plays in a game for 12 minutes, which was none of the games, so that's kind of why they're asking about this, and then show or explain how we got the answer. So we've already drawn this line of best fit back in part B. So we can actually just look up what an input of 12 gives us for an output on this line. So at 12 minutes, we are here at 6 points. So using this line of best fit then, we might expect that she would score 6 points in that game. For the final part of this problem, they want us to create a linear equation that could represent the data. So we've got this line of best fit that we've drawn. Again, we're just going to use that for this problem and create an equation that describes the line. Now we really have kind of two go-tos when we look at a graph and we're trying to come up with the equation of a line. There's the point, or the slope-intercept, y equals mx plus b form. That doesn't work so well initially on this one because we don't really know the y-intercept. It's going to be somewhere in negative territory. There's also the point-slope form of a line. That's this one here, y minus y1 equals m times x minus x1. That's another way to approach this problem where we can immediately plug something in. So I'm going to use this, but you actually could use y equals mx plus b. You can find the slope either way. If you're going the y equals mx plus b route, you'd have to plug in one of these points and then solve for the b value. So that's one way to do it. Using this form of a line, though, gets us an equation a little bit more quickly. So I'm going to use a point that the line goes through. I'm going to use the point 14, 10 right here. That's an easy one that it goes through. And I'm just going to plug in my point for x1 and y1. And then I'll also find the slope and plug that in for m. So my y value I'm using then is going to be this 10 right here. So I'm going to write y minus 10. For my slope, to get from one point to another on this line, I'm going up 2 and over 1 grid lines. Now we have to be careful because the grid lines are not going by ones. However, the grid lines are going by the same intervals. They're all going by 2s. So if I think of my slope as up 2 and over 1, this is really up 4 and over 2. But it's still a ratio of 2 to 1. So I can write 2 for my slope, and then I'll have x minus this x value here, which was 14. They said create a linear equation. This is a linear equation, so this actually should be good enough. But if you wanted to turn it into slope-intercept, you could. So we could distribute this 2. That would be 2x minus 28 over there. And then adding the 10 over here would give us 2x minus 18. So that would have been our y-intercept if we tried to do it that way. For this problem, we're told that a student drew right triangle XYZ, and it had these angles. X was 39 and Z was our right angle of 90 degrees. We want to know which is equivalent to the sine of X based off of that. So I think the best way to start this problem would actually be to draw this right triangle and kind of get a picture of what we're looking at. So here is a right triangle, and putting in the angles that they've given us here, they told us X was 39, so I'm going to make that one of the non-right angles here. I'll make it this one down here, and I'll put 39 there. And they told me Z was 90, so I'm going to label this one as Z. And that means that Y is going to be my other angle, and I can actually calculate that. Since there's only 90 degrees left over if I've already used up this right angle, that means that Y is going to be 90 minus 39, which comes out to 51 degrees. So I'll put that in here as well. And we noticed the 51 in the answer choices, so that tells me I'm on the right track here. Okay, so sine of x. What is sine of x? Well, sine of x, in general, using our SOHCAHTOA sort of way of thinking about things, sine is the ratio of the opposite side and the hypotenuse. So here's x. The opposite side from that is this yz side, and the hypotenuse is xy. So we can say that sine of x is going to be yz over xy. We don't know how long any of these sides actually are, but we have to take one of the answer choices that's going to give us the same ratio of sides in the same order, and that's going to be our answer. So let's just look at some of our options here. So we've got cosine of 39. So cosine is adjacent over hypotenuse. So that would be this touching side, this xz side over xy, which doesn't match what we had for sine. So cosine of 39 doesn't work. How about cosine of 51? Well, cosine of 51 is really the cosine of this y angle. And cosine, again, is adjacent over hypotenuse. The adjacent side for y is this side here, this yz side. Hypotenuse is still x over or xy. So our cosine is yz over xy. So that suggests that the cosine of 51 and the sine of 39 are the same thing. And in fact, if you know a little bit about what cosine means complementary trig function. That's what the co means. So in general, the cosine of an angle and the sine of the complement of that angle, the 90 minus version of that angle, are always going to be the same thing. So this totally makes sense. But let's just look at some of the other answer choices. Tan of 51, that would be opposite over adjacent. That's the TOA part. So that would be xz over yz, which doesn't match. And tan of 90, well, you really actually can't talk about the tangent of a right angle because, I mean, opposite, sure, that's the hypotenuse, but what's the adjacent side, right? These are both touching sides. So that's just kind of a nonsense number anyway. So at the end, choice B is our best answer here. On this problem, we're told that two lines are graphed on a coordinate plane, and here's the equations of the two lines. We want to know which of the following is the x-coordinate of the point where these lines intersect. So there's a number of options we have for trying to figure this out. One would be to draw a little grid and try to accurately graph this and actually see where they cross, and you might be able to pull that off. This negative 22, though, is a little bit weird, so and this 6 is kind of a steep slope, so I think it might be difficult to do that with a graph. The other options are the algebra methods, substitution or elimination. Now, elimination works great if you can add the equations together and quickly cancel out one of the variables. And we could almost do that. If we multiplied one of these by -1, a negative y and a positive y would cancel if we added these. An even faster way, though, would be the substitution method. Since we have y isolated in both equations, we can just take one of these y's and replace it with the stuff that the other y equals. So, for example, I could swap out this y down here with negative 3x plus 5. And then I'll have negative 3x plus 5 equals 6x minus 22. Since I just have x's now, I can just solve for x, and that's the coordinate we wanted anyway. So if I subtract 6x from both sides, that'll be a negative 9x on the left side. And then if I subtract 5, that'll give me a negative 27 over on the right. Dividing both sides by negative 9, we end up with x equals 3. Now we could plug this back into either of these equations to find the y value that goes with it, but we actually have done what they asked, found the x value, so that's going to be choice B. For this problem, they've given us the first 4 terms in a geometric sequence, and they want us to say which expression represents the nth term of this sequence, given that n is going to be greater than or equal to 1. So the basic idea is we took the whole numbers, 1, 2, 3, 4, 5, all of those, and plugged them into one of these formulas here, and that's how they're generating this list. One way you could do this is just to take 1, 2, 3, and 4 and plug them into these different expressions until you get a set of numbers that matches the 4, 12, 36, and 108. That would be a fast way to do it, fast enough way. Another way you could do it is just to, if you know a little bit about a geometric sequence, that means we have a common ratio. Since we have a common ratio, we can use the general geometric formula. A sub n equals a1 times r to the n minus 1. This is sort of the y equals mx plus b of these sorts of sequences here. So the a1, that's the starting value. That's going to be 4. And then for the common ratio, to get that, you just take any term and divide it by the term before it. You're basically asking, what do I have to keep multiplying by to get the next number? So if we do 12 over 4, for example, that would give us 3. And we could also have gotten that with 36 over 12 or 108 over 36. So plugging all that in, then we're going to have 4 for my a1 times my r value of 3 to the n minus 1. And if we look, that's going to match choice B. For this problem, they're telling us that triangle UVW is congruent to triangle XYZ. They didn't actually draw any of these for us to look at, but they want to know which of the following 3 things has to be true. So we need to know a little bit about the system of naming things congruent. The basic idea when you say 2 things are congruent is that the individual angles in them, and the order that they're written in is telling you which angle is congruent to which other angle. So the first angle in the first triangle and the first angle in the second triangle, they're telling us that these are congruent. This is implicit in them giving us the statement in this order. So that means that U and X, those angles are congruent. Same thing with angles V and Y, and angles W and Z. So that's some of the answer choices that we're seeing here. Before we pick our answers, though, we're also going to talk about which sides must be congruent. Now, the segments that have to be congruent, it's the same idea. You have to write the letters in the same order. So, for example, segment UV and segment XY, those are congruent. Same thing with UW, the first and the third letter there, and XZ. And then finally, VW, the last two letters, and YZ. So looking through our answer choices, let's see choice A, UV and XY. Are those on our list? They are. So we can use answer choice A. For B, VW and XZ, nope, XZ and UW go together. So choice B, we're not going to use that one. For choice C, we've got angles V and Y. Yep, that's on our list. Choice D, we've got U and X, also on our list. And that's 3, but just looking here, choice E, W and X, nope, W goes with Z. So that was choices A, C, and D that matched our list. On this problem, we're told that two students are each writing a polynomial expression. Student A wrote this expression here, 2x times x minus 4. They want to know which is equivalent to this expression. So all of these expressions in the answer choices, you'll notice none of them have parentheses. So it looks like we must have distributed this 2x to get rid of that parentheses. So if we do that, 2x times x gives us 2x squared, which all the answer choices have. And then 2x times negative 4 is going to give us negative 8x. So that's all going to match answer choice D. For student B, they wrote this crazy polynomial expression here, and then they correctly simplified that by multiplying this together and combining all the like terms. We want to know how many terms would be in this student's simplified expression. Well, we can actually eliminate some answer choices right off the bat just by knowing the highest exponent here. If we start multiplying this out, x times x squared, that's going to give us our highest exponent, which would be x to the third power. So that's the highest. We might also have an x squared, an x, and a constant in there. But at most, we're going to have 4 terms. We can't get anything higher than x to the third power out of this. So that means that the answer could be 4. It definitely cannot be anything higher like 5 or 6. So C and D we can get rid of right away. Now the question is, do we know for sure that there are exactly 4 terms after simplifying? And unfortunately, we don't know that without multiplying this out. Although there are often 4 terms in this situation, sometimes one of your other terms, the x squared, the x, or the constant, might cancel out with something else. Specifically, the x squared or the x could cancel out. So we might actually end up a term short and have only 3 terms. So unfortunately, the only way to be 100% sure about this is to actually multiply this out ourselves and combine like terms to see how many we end up with. All right, so I'm going to use my distributive property to break this up and multiply it out. So I'm going to do x distributed to that whole second parentheses, and then I'm going to also do negative 2 distributed to that whole second parentheses. So I'm breaking it up into 2 distributive kind of problems. Now just distributing each of these individually, I've got x and x squared gives us x cubed, and then x times 3x is 3x squared, x times 1 is a plus 1x, negative 2 times x squared is negative 2x squared, negative 2 times 3x is negative 6x, and negative 2 times 1 is going to give me negative 2. Combining like terms, x cubed is the only x cubed, so I'm just going to rewrite that. 3x squared and negative 2x squared can combine because they have the same exponents, so that will give us 1x squared. And then we have x minus 6x, that's going to be negative 5x, and then finally negative 2. So counting these up, we've got 1, 2, 3, 4. So it is the typical case of 4 terms, which means that we can now definitively choose choice B. For this question, they give us this linear function on the coordinate plane here, and they want to know which of the following graphs represents f of x minus 2. So if we have this minus 2 happening outside the function, the fact that it's outside tells us that this is going to be a vertical change, and since it's outside, the change is going to be exactly what it looks like. So we're literally subtracting 2 from all the y values of the function. So visually, this is going to give us a translation of 2 units down. So that means that we're not changing, we're not flipping anything or rotating anything. So at the very least, we should have a graph that is sloping in the same direction. That allows us to immediately eliminate answer choices C and D, which are sloping up, not down. So that narrows it down to choices A and D. So looking at these, I'm just going to look at the y-intercept. That's the easiest one to spot. I started with a y-intercept of 3, so if I'm shifting down 2, that y-intercept should now be 1. Looking at my answer choices, choice A has a y-intercept of 1. Choice D has a y-intercept of 0. So D, they went too far, so I'm going to go with choice A. For this 4-part problem, we have 4 students studying expressions. Lionel writes this radical expression, square root of 16 squared, and we want the value of Lionel's expression. Show or explain how he got your answer. Okay, so there's a lot of ways to do this. The simplest way would probably be just to take the square root of 16, which is 4, and then square that, giving us 16. Another way to do it is you could say that square root and square are inverse operations and cancel each other out. So we would end up with 16 that way as well, but you'd have to write a bunch of words to show that, whereas this is just a couple numbers. For part B now, we have Edith writing 25 to the 1/2 power squared, and we want to know the value of Edith's expression. So one way to do this problem would be to remember that a fractional exponent is really just a radical kind of expression. The number on top here, the numerator, is the power, and the denominator is the index of the root. So this would be the square root of 25 to the 1st power. So that's one way to do the problem. Another way to do this would be using properties of exponents. We know that when we raise one power to another like this, or an expression with a power raised to a power, we are multiplying the exponents. So this is really 25 to the 1/2 times 2. Now we know that 1/2 times 2, the 2's cancel, that's just 1. So this is really just 25 to the 1, and anything to the 1st power is itself. So this is another way of doing it. For part C, Walter writes this expression, n to the 1/4 to the 3rd, and they want us to say which of these radical expressions is equivalent to Walter's expression. So in order to match one of these, I'm first going to simplify this to get a single fractional exponent. So again, I'm multiplying the exponents when I raise something with a power to another power. So this is n to the 1/4 times 3, which is just n to the 3/4. And the 4 here, the denominator, this is going to be the index of my radical. So this is going to be n 4th root of n. The 3 is the power that's going in there, so this is going to be n cubed. So when the dust settles, I have n to the 3rd power, 4th root of n to the 3rd power. And does that match any of my answer choices? A is close, but I've got the 3 and the 4 mixed up there. C is nowhere in the neighborhood. Neither is D. That 13 is kind of weird. But B, 4th root of n to the 3rd, that's what I need. For the final part of this problem, Gloria writes the cube root of x squared, and they're telling us that this is equivalent to 4. We want an x value that actually makes that true. So I'm going to set this equal to 4 then, and then I'm going to solve this equation. Now there's 2 things I have to undo to solve this equation. I need to undo this cube root, and I need to undo this square. So first thing I'm going to do is to get rid of the square, I'm going to square root both sides of the equation. But I have to be careful when I do this, because when we square root equations, unless we have some compelling reason to think otherwise, we always end up with a positive and a negative root. So I'm going to write cube root of x equals plus or minus square root of 4, so plus or minus 2. Next up, to get rid of the cube root, I have to raise both sides to the 3rd power. So I've got x equals, and then both positive and negative 2 being raised to the third power. Since an odd exponent keeps the sign of the original, I end up with both a positive and negative answer, plus or minus 8. For this next problem, we have this parallelogram, PQRS, and some diagonals, and we also have some expressions representing the measures of certain angles here. So for part A, they want to know which of the following statements is not true. So we're going to go through each of these statements and see if we can figure out what makes it true or not true. So our first statement, PQ congruent to SR. So here's PQ, here's SR down here. This is a parallelogram, and those are opposite sides in a parallelogram. We know that opposite sides are congruent in a parallelogram. That's one of the properties. So this is actually a true statement. On to B, we've got PT and RT congruent. Now, we know that the diagonals of a parallelogram do bisect each other. That's another one of the properties. So that means that these two segments are also going to be congruent. So that's also true. Next, we have PR, that's this diagonal, and SQ, that's the other diagonal. And they're saying those are congruent. And I mean, you can tell just by looking at the picture that this does not appear to be the case. But we also know that parallelogram diagonals do not have to be congruent. Rectangle diagonals would have to be congruent. But that's a special case of a parallelogram. This is not necessarily a rectangle because they didn't say so, and there's no way to prove it is. So this one is going to be false. It's not necessarily true. Just to be on the safe side, though, let's look at the last one. PS and QR congruent, and these are also opposite sides. So like choice A, where opposite sides were congruent, this is also going to be a true statement. So that means that C is the only false one. For part B, they want us to find the measure of x in this diagram. So the key is being able to relate these two different expressions that have x's in them. Now, we know that this is a parallelogram. That means we have two sets of parallel lines. That makes these angles alternate interior angles. They're on opposite sides of the same transversal cutting through two parallel lines. We know that alternate interior angles are congruent. That's one of our alternate interior angle properties. So that means basically I can set 45x and 21x plus 16 equal to each other. Now I just have to solve for x. So subtracting 21x, that'll give us 24x equals 16. And then dividing both sides by 24, we have 16 over 24, which I can reduce to 2/3. And that's going to match answer choice A. For this problem, they're giving us a line on this coordinate plane, and they want to know which is the best equation to represent this. Since this line is going through a y-intercept that I can easily pick out, this -6 here, I'm going to use y equals mx plus b form, slope-intercept form. So I have a slope. We are going, let's see, down 2 over 1, so -2 for the slope. And then for the y-intercept, again, that's this -6. So just putting all that together, we have y equals -2x minus 6, and that's going to match answer choice A. For this next problem, they want to know which two of these expressions have a value that's rational. So this is a good one for process of elimination. Let's go through and see whether each of these is rational or irrational. So pi itself is an irrational number, and maybe you're not sure what happens if you square it. It does end up being irrational, but we can't assume that just because we're squaring an irrational number, it's going to be rational. The square root of 2, for example, if I square that, becomes the rational number 2. In this case, though, pi is kind of a special case. Now, how about pi plus 3? Well, if I take something that's a non-repeating, going forever kind of decimal, and I add 3 to it, that's not going to change the decimal problem with it. So this is also going to be irrational. Let's take a look at this next expression now. 2 times the 5th root of 3 raised to the 5th power. So I can actually simplify this a little bit. I can raise the 2 and the 5th root of 3, each of them individually, to the 5th power. 2 to the 5th is 32. And the 5th root raised to the 5th, those are actually going to cancel, leaving me with just 3. 32 times 3 is going to be a rational number. It's the number 96, but it's rational is the important point here. Now for this next one, we have 2 to the third plus, well, what is this? If I raise the square root of 2 to the fourth, that's really like having the square root of 2 squared and then squaring that again. Square root of 2 squared is just 2, so this is really like having 2 to the second. 2 to the third is 8, 2 to the second is going to be 4, so that's going to be a grand total of 8 plus 4, or 12, which is rational. So that's the second one that we were looking for. Just to verify, though, this last one, 5 radical 2 minus 4 radical 2, we're just going to keep the radical and subtract the coefficients. So that's 1 radical 2, which is irrational. So definitely choices C and D. On this problem, they want us to say which of these graphs could be the inequality that they've shown here. So I'm going to take a look at a few different properties to sort of eliminate my wrong answer choices. First thing I notice very quickly is that we have a y-intercept of 4. And looking at these graphs, C and D don't have the correct y-intercept, so already I can eliminate those without doing any other work. Now it's down to A and B. Another easy thing I can look at to see which one is which is the inequality. Since this is greater than, that means we should be shading above. So the only graph between these two where I'm shading over the line is going to be choice B. Choice A we're shading under. So choice B it is. For this problem, it's a two-parter. In the first part, we have an athlete kicking a soccer ball up from the ground, and here's the graph of the height of the ball. Based on the graph, we want to know after how many seconds did the ball reach its maximum height. Well, the maximum height happens at the vertex right here. So we're basically asking what is the t value that gives us this highest h value. So that's happening at our vertex, which has a t value of, well, this is halfway between 2 and 3, so 2.5 seconds. For the other part of this problem, they said after 1 second, the soccer ball reached a height of 64 feet. Over which interval of time in seconds was the height of the soccer ball always greater than 64? Well, if this happened after 1 second, then these intervals that have 0 in them probably don't make a whole lot of sense. So realistically, we can narrow this down to 1 to 4 or 1 to 5. Way to do this now using our graph is we can actually draw in a horizontal line at roughly 64 feet. So that would be right about here. This is a half a grid line since these are going by tens. So let's just see what t values keep our graph above this line that we just drew. So definitely roughly 1 for the starting t value, which is what they said here. But also over here, that it dips back below our line over at 4. So from x equals 1, or actually I should say t equals 1 to t equals 4. There we go. I mean, they are basically x values, but let's use the variable in the graph. So from 1 to 4 is giving us choice C. On this one, the number of home runs hit by a baseball player in 10 seasons are listed below in this box here. They want to know which of the following statements will be true if the outlier is removed from the list. So who's the outlier here? So this would be, it's always going to end up being either the lowest or the highest value in the list, and it's going to be whichever one is furthest away from the rest of the data. So our highest number is 50, our lowest number is 8. And looking at the rest of these numbers, I would say 8 is closer to all the rest of these numbers than 50 is. So 50 is going to be our outlier. Now if we remove 50 from this list, since we're removing a huge chunk of the total number of home runs, that's definitely going to decrease the average or mean value of the whole list. So I would say any answers that say the mean is going to stay the same should be eliminated. So choice B and choice C right off the bat, we can get rid of those. So the real question then is what's happening to the median? Is it also going to decrease, or is it going to stay the same? And we have to be careful here, because removing something from the end of a list doesn't necessarily change the value of the middle item. So we actually do need to calculate the old median and the new median and see if those match. So for getting the old one, we have to put these in order. So I've got 8 is our first number, and I'll just cross this off as we go. So let me see here. All right, so there we go. And then next we have, let's see, after that we're going to have 12 looks like the next lowest. So cross that one off. And then 13. And after that, what's next? 16. And then we have a couple of these 18s, so let's cross those off. And then after that we've got 19, 21, and let's see, 24, and then finally 50 is our outlier. All right, now to find the median here, I need to cross off pairs of numbers. So let me do 8 and 50, and then I'll do 12 and 24, 13 and 21, 16, 19, and that leaves us with 18 and 18. So those average together to give you 18, which is the old median. All right, now let me just erase all that, and let me just pretend this outlier doesn't even exist. And now let's find the median based on the remaining items. So now we would cross off 8 and 24, 12 and 21, 13, 19, and then 16 and 18, and that would leave us with a new median of, right here, we've got 18. Well, since the new median and the old median match, that means the median is staying the same. So we have the, let's see, the mean will decrease and the median will stay the same. That's going to be choice D. For this problem, we have a circle being graphed on a coordinate plane, and the equation of the circle is shown right here. X minus 2 squared plus y plus 1 squared equals 4. We want to know which of these two statements here are true. So it's good to remember the general formula for a circle. X minus h squared plus y minus k squared equals r squared. H and K give us the center, and R is the radius for something in this format. So that means that our center is going to be positive 2, because H is initially being subtracted here, and then it's going to be negative 1. This is y minus negative 1. That's our K value is negative 1. And then for the R, we have R squared equals 4, so therefore R is going to equal 2. I mean, technically you could say plus or minus 2, but the radius really shouldn't be negative. So what matches those, what does this match with our answer choices? So we have the coordinates of the center, and there's 3 different options for those. Choice A is the one that's correct out of those. And then for the radius, it's choice D, 2 units. So A and D. For this problem, this is the last problem in the no calculator section. They're saying there's a linear relationship between the price of a car and the amount of deposit required by the dealership when the car is purchased. Which table could represent this linear relationship? So we have all these tables with columns where the price of the car is going up in increments of 5,000, and that's affecting the deposit on the right side. All right, well, the easiest way to find a linear relationship, since my left column is going by the same increments, I can see if my right column is also going up by the same amount each time. It might not be the same amount as the left side is going up, hopefully not, because the deposit should not be going up by 5,000 each time, but it should be going up by the same number, whatever that is. So I'm just going to test out each of these tables to see where that's happening. For table 1, table A, getting from 100 to 200, that's a first difference of 100. But then from 200 to 400 is a jump of 200, so that's a no. That can't be linear if that difference is going up. For table B, 750 to 1,000 is 250. 1,000 to 750 is 750. That is too big of a jump as well, so that can't be linear. And then this next one, we've got 100 to 200 is 100. 200 to 500 is a 300 difference. Too big, so nope. And then in this last one, just to double check, 750 to 1,000 is 250. It's another 250 to 1250. another 250 to get to 1500, and 250 to get that last increment accomplished as well. So this is a yes. So then choice D is our linear relationship.